Good morning, everyone. Let me introduce myself to you. My name is Teja. I am studying Mechatronics, Masters of Engineering in VIT Chennai, Vellore Institute of Technology, Chennai. And now my topic is about the 6 degrees of robot for screwing and unscrewing operations. This is set to do by our professor R.O.K. Selvakumar sir, and he guided me in every aspect to do the project. Let's go to the introduction part of the robot. It is a 6 degrees of freedom robot, commonly called as a 6 DOF robotic manipulator, and its application in performing the tasks very well in screwing and unscrewing on a surface. And this 6 degrees of freedom is a robotic arm that has 6 independent joints on axis of movements, and this independent joint has each rotation, and which we have to calculate the forward and backward kinematics, and this, which we can say it as yaw, pitch and roll for these 6 degrees of freedom. As on these industrial terms, this is used for industrial automation and assembly lines, welding and precision tasks to do very particularly and accurately. And coming up to the degrees of freedom, we have 6 degrees of freedom in this robot, and what actually the degrees of freedom is represents as joint or the axis in the robot, given in one degree of freedom, basically one independent way the robot can move. The first, as per on this 6 degrees of freedom, the first 3 joints are positioning, and the last 3 joints are orientation, and this the tool or the rotation motion will be tilted in the end of the part. That is we can call as end effector. And coming to working principle, there are 6 types of working principles are there in this, but we can know. Coming to working principle, we have initialization, positioning, alignment, screw action, unscrew action, completion. And coming to hardware setup, we have this hardware setup in our hand. This is the hardware setup. So this is the 6 degrees of freedom robot manipulator that is which it can move in any direction. This is called this 360 degrees rotation, and this is up to 180 to 180 degrees rotation, and this is also like this, only 180 to 180 rotation. If at all there is no adjustments like this, the robot can't able to move very easily. And this is the end effector part, that I am choosing the screw here to insert any type of screws model that it can be rotated, and that for rotating we are using Arduino. This is the Arduino. This is Arduino Mega 2650. This is the microprocessor and microcontroller that we can use, and this is the motor driver. The working principle of the motor driver is to give the input to rotate all the motors at a certain speed. That is called a motor driver, and we should have to insert a 16 volts, 12 volts to 16 volts battery to rotate the motor for this manipulator. And coming to applications for this. We have the electronics and automotive sector and aerospace sector and industrial automation. This we can give it as it can do it can give as a productivity, safety and quality control for this manipulator. And coming to advantages, there are n number of advantages, but we, as per on the terms, we say some only. There are high repeatability and accuracy, and can easily programmed and do different tasks for each and product. I mean, for what which we have required product. It reduces the human error, and without, it is a humanoid robot, so it can reduces the human effort, and it is the ability to reach complex angles and confined shapes and space. And coming to conclusion part, this is the working only. The conclusion part, I should has to do this working in front of you. Wait for a few seconds that it should be work. This is the programming that I am doing in Arduino IDE second version, and now I have clicked uploaded, so it's uploaded. See, like that, it's moving slowly without any battery. I have given just to show you guys that it will rotate. See, it's rotating slowly. This is first degree, and the base one, that is, this is the base. This is the second degree that I have given. So, it's rotating slowly, that you can see. So I have given delay time to rotate slowly, so it's rotating step by step, and I have adjusted the speed also for the base. See, I have given these directions to change the angle from 180 to minus 5 degrees, so that is what that is changing. And now let us go to this angle, second degrees of freedom. This is the second degrees of freedom. It is also rotating slowly, that I have given very less speed to rotate. That you can see in this video. And now let's go to the third degree of freedom. This is the third degree, so let us go to third. That you can see, I have given to the third degree of freedom. I have given a very less timing for this also, to rotate slowly. Yeah, this is the fourth degree of freedom, that I have given somehow speed to rotate fastly. This is how it's rotating. Before that it's rotating very slow, so that's why I have changed this to rotate very fast. This is the 5th degree, and now let's go to 6th, sorry, this is 4th degree, and now let's go to 5th degree. See, that is the 5th degree of freedom. This is rotating. Again I have reduced the speed of this 5th degree because it's rotating very fast, so that and now we are going to 6th degree of freedom. See, that is the 6th degree of freedom that I have attached the screw for this rotation to unscrew and to the screw. So thank you. Yeah, that's all. How now, just now we have learned how the working process has been done, and in Arduino software we are using the software Arduino IDE, and we can do it on MATLAB also. And for using Arduino, we have to install servo.h library and myservo.attach also for the signal pin, and the loop gradually changes the servo position between 0 degrees to 180 degrees. Like this we can adjust this into by controlling by using potentiometer also, 10K potentiometer. Based on this we can do n number of projects with these servo motors and these sensor inputs, and we can modify whatever we want as per the coding that which we have given, and as per the natural speed we are giving the programming only, that is only the natural that we have giving speed. And as per the screw and unscrew bolts, that we can do it in a mechanism, that is the tool attached at the end of the arm. It is fitted with a screwdriver mechanism. The robot is controlled to move forward and to move backward, like this, and to align the tool correctly, and then apply rotational motion to either tighten or loosen the screw. This operation combines both the linear motion and the rotational motion, which makes it good example for studying kinematics and the control in the robotics. Not only in kinematics, the inverse kinematics also we have to do for this process. That's all. I hope you enjoyed a lot by doing this robotic manipulator project. Thank you. As per my professor guidance, I have done everything what he said, and I am saying thank you to Arokya Salokumar sir. Thank you for giving me this opportunity to teach someone that anyone can learn this one, robotic systems and this 6 degrees of freedom manipulator. Thank you.